How exactly does the internet work? When you send a message, stream a video, or join an online game, how does your device actually communicate with the computers on the other side of the world? The answer is in something called the OSI 7-layer model, a framework that explains how data moves through networks step by step. Every time you send information online, it travels through these 7 layers, and the same happens in reverse when it reaches the other person. So let's break it down, layer by layer, to really understand what's going on under the hood. OSI stands for Open Systems Interconnection Model. It was developed by the International Organization for Standardization, or the ISO, back in the 1980s. It's not a protocol or a piece of software. It's a conceptual model, and it gives you an expectation for how devices are supposed to communicate. Each of the 7 layers has a specific job, and together they make sure information can travel from one computer to another, no matter what hardware, operating system, or network type they're using. To make things easier to imagine, let's use a classic example. You're sending a message to your friend online. Your computer goes through all 7 layers to prepare, send, and deliver that message. Let's start from the top. Firstly, we start with layer 7, the application layer. This is the layer closest to you, the user. When you type in your message into WhatsApp, Discord, or Messenger, you're interacting with the application layer. This layer doesn't mean the actual app itself, but the protocols and services that allow the software to communicate over the network, like HTTP, FTP, SMTP, or DNS. So in our example, when you hit send, the app uses a protocol, let's say HTTP or SMTP, to format your message into data that can be transmitted. It also attaches metadata, like who the message is for and for what kind of data it is, text, image, files, etc. This layer makes sure the data request makes sense to both the sender and the receiver. Once your message leaves the application layer, it moves down to the presentation layer, sometimes called the translator layer. Its main job is to make sure data is presented in a format that both ends can understand. Here's where encryption, compression, and data formatting happen. If your message is encrypted with SSL or TLS, like in HTTPS, this is the layer that handles that. It can also compress data to make transmission faster, and it can convert data between formats, for example text to binary or vice versa. Without the presentation layer, 2 computers might literally be speaking different languages. The session layer manages the session between devices, basically the conversation itself. If the application layer is like you writing a letter, and the presentation layer is sealing it in an envelope, the session layer is making sure the phone line between you and your friend actually stays open. It sets up, maintains, and terminates the connection. Imagine a video call. The session layer ensures your computer and your friend's computer know when the call starts, stays active, and ends properly. It can also manage multiple sessions at once. For example, when you have several browser tabs open, each communicating separately with different websites. The transport layer ensures that data is transferred reliably and in the right order. It takes a large chunk of data from the upper layers and breaks it into smaller manageable pieces called segments. Then it numbers them, adds error checking info, and prepares them for transmission. This layer also controls how fast data is sent, so the sender doesn't overwhelm the receiver. There are 2 main protocols at play here, TCP and UDP. TCP, or Transmission Control Protocol, is reliable but much slower. It ensures every piece of data arrives correctly and resends any missing parts. It's typically used for messaging, emails, or web browsing. Essentially anything that's not real time and needs every single bit of information. UDP, or User Datagram Protocol, is faster but less reliable. It's used for time-sensitive things like gaming, voice calls, or video streaming, where you can afford to miss out on a couple of frames, for example. So in our message example, TCP is making sure your text message arrives completely in the right order, without duplicates. If even one bit goes missing, TCP will resend it automatically. Now the network layer steps in, and this is where your message learns where to go. It handles logical addressing, using IP addresses, and decides the best route for your data to reach its destination. Routers operate here, forwarding data between networks. So when your message leaves your home, the network layer decides how to send it across the internet, through routers, data centers, and different networks until it reaches your friend's device. This layer calculates the fastest or most efficient path. If one route is congested or fails, it can reroute automatically. The main protocol here is the Internet Protocol, or IP, which works with TCP or UDP to deliver packets to their destinations. Now we're getting closer to the physical side of things with the data link layer. This ensures data can travel between devices on the same local network, for example between your laptop and your Wi-Fi router. It packages the data into frames, as the senders and receivers' MAC addresses, and performs error detections using things like checksums or CRC. Switches and network cards operate here. If the network layer is like a postal system choosing a delivery route across countries, the data link layer is like the local delivery van that handles transport from your house to the nearest post office. Without it, the data would never leave your local network. And finally, the physical layer. This is where all those ones and zeros actually move. It's the hardware, cables, fiber optics, radio waves, electric signals, and network interfaces. This layer defines how bits are physically transmitted, voltage levels, signal timing, pin layouts, and so on. So when your message leaves your device, it's converted into electrical pulses or light waves that travel through wires, or into radio signals that travel through the air for Wi-Fi or mobile data. This is the foundation. Without it, no communication would happen at all. So let's trace the full journey. You type a message in WhatsApp, which is the application layer. It's formatted and encrypted, the presentation layer. A connection session is established, the session layer. The message is broken down into segments and prepared for transmission, the transport layer. IP addresses are added to it and routed across the internet. The network layer. It's wrapped into frames for your local network, the data link layer, and finally it's turned into signals that physically move through your router and out into the world, the physical layer. Then the same thing happens in reverse on your friend's side, going down from the physical layer all the way up to the application layer, until their phone shows your message on screen. Now you might be thinking, cool, but do we actually use the OSI model today? Well, not exactly. The internet mostly runs on the TCP/IP model, which simplifies these 7 layers into 4 broader ones. But the OSI model is still incredibly important for understanding how communication works, and is the foundation of networking education, cybersecurity, and troubleshooting. For example, if you can't connect to Wi-Fi, then it's likely a layer 1 or a layer 2 issue. If a website won't load, maybe it's layer 3 or layer 4. And if your messages are encrypted incorrectly, then you know you have to debug with layer 6. Understanding the OSI layers helps engineers pinpoint when something's gone wrong, saving hours of guesswork. So the next time you send a meme, hop into a voice call, or stream your favorite show, there's an invisible chain of 7 layers working together to make it all possible. The software you use, right down to the electricity and the light carrying your bits and bytes. The OSI model is the reason the internet works. Thanks for watching. If you found this breakdown helpful, hit that like button, subscribe, and comment any questions you have. See you next time.